And welcome back. Let us learn combination of solids. For example, here you can see a cylinder. And a cone is mounted on it. So there are two shapes. You can see a cone and a cylinder. It's a combination of solids. Two solids, cylinder and cone. Okay. And other example, when a cylinder is given and we drilled out a conical cavity from it. So there are two shapes. You can see how can we find the remaining solid, volume of remaining solid or surface area of remaining solid. So we have to consider both equation, that is the volume of cone and volume of cylinder. So these type examples we will discuss. And the topic sphere is not in your syllabus and the problems related to it also. And combinations with the spheres and hemispheres can be avoided. That's why exercise 20C, 20D and 20E we can avoid. Some problems may be there with the cylinder and cone only, that you can solve, no problem. Now we are going to discuss exercise 20F. First one, from a solid right circular cylinder with height 10 centimeter and a radius of base 6 centimeter, a right circular cone of the same height and same base is removed. Find the volume of the remaining solid. That is the first question. Let us solve that. So here is the cylinder of height 10 centimeter. So the height of the cylinder is 10 centimeter and base radius is 6 centimeter. This is R equal 6 centimeter. And from this right circular cylinder, a right circular cone of the same height, same height and same base. So the same base, how can we draw the cone? Yes, maximum height, same height itself, that is given in the question. Height of the cone is same, 10 centimeter is removed. Find the volume of the remaining solid. How can we find the volume of remaining solid? Volume of remaining solid can be calculated by, yes, subtracting the volume of cone from the volume of cylinder. Okay, volume of cylinder minus volume of cone. Okay, solve the problem. What is the volume of cylinder? Can you say the equation to find the volume of cylinder? Yes, pi r square h. And what about the volume of cone? Yes, 1 by 3 pi r square h. And it's a direct question. R and h are given in the question. So just apply that in the formula and find out the value. Let us solve. That's equal to pi r square h minus 1 by 3 pi r square h. Here the radius and height are same for the cone and cylinder. That's why no change in the letters. Small letter or capital letter or no need to replace like that. We can use the same R and H here. Substitute. Pi is common here and also R square is common. H also common. 1 minus 1 by 3. 22 by 7 into radius 6 square into height 10. What is 1 minus 1 by 3? 3 minus 1, 2 by 3. So we don't want the bracket, into 2 by 3. Okay, we can cancel out 6 and 3. 22 into 6 into 6 into 10 into 2 by 7 into 3. 3 2s are 6. And multiply the values and divided by 7, you will obtain the remaining volume of the solid. That's equal to 5280 by 7, or you can divide and write in mixed fraction as 754 2 by 7 centimeter cube, or you can write in the decimal form also no problem. Now second and third homework. Question number 2, question number 3 homework. And question 4. A circus tent is cylindrical to a height of 8 meter surmounted by a conical part. Let us draw the diagram. Circus tent is in the shape of cylinder. First part is of cylinder and surmounted by, that means the top portion is conical part. That is from this top there is a cone shape. This is the shape of a circus tent. If total height of the tent is 13 meter, that means from the base to top, total height of the tent means this, from this height to base. Total height is given as 8 meters. Sorry, 13 meters. Cylindrical to a height 8 meter. That means the height of the cylinder. This height is 8 meters. If the total height of the tent is 13 meter and the diameter of its base is 24, this total diameter is 24 meters. So can you say what is the radius? It's a half of it, no? Yes, radius equal to 12 meters. So we have the radius, two heights are also given, and first question is total surface area of the tent. How can we obtain the total surface area of this tent? Yes, surface area, curved surface area of the base is not there for the tent. So curved surface area of the cylinder plus curved surface area of the cone. So can you say what is the equation to find the curved surface area of a cone? It's pi RL, no? So we need the value of L, slant height. We know the radius is 12 meter. The base is 12 meter radius, so here also 12 meter. And what about the height of the cone? How can we obtain the height of the cone? It is not given directly in the question. Total height of the tent is 13 and the height of the cylindrical portion is 8. So we can obtain the height of the cylinder as 13 minus 8. Okay, here we can apply the 8 meter only. And what is the height of the cone? That is 13 minus 8. 5 meters. Okay, so we have the height and radius. So how can we obtain the slant height? Yes, we can apply Pythagoras theorem. This is a right angle triangle. So L is equal to square root of R square plus H square. Do that to obtain the slant height. Then 2 pi RH we can apply here. We know the radius and height of the cylinder. So we can apply that value also. For that we can write this as H. Okay, this is H1 and this is H2. Height of the cylinder as H1 and height of the cone as H2. Second height, and that is the first height. That means we consider the first solid as cylinder and the second solid as cone. So to identify that we can place H1 and H2. Radius is same, that's why R enough. Okay, let us do the first question. Before that we need to calculate the L. L is equal to root of H1 square plus R square, H2 square, sorry, that is of cone. Square root of 5 square is equal to root of H2 square plus R square, that is square root of 5 square plus 12 square, that is square root of 25 plus 144, that is equal to 169. Do you know the square root of 169? Yes, that. So square root of 169 is 13 centimeter. Thus we obtained the value of L. Now the first question. Surface area of tent. Surface area of tent is CSA of cylinder plus CSA of curved surface area of cone. So we know the equation. What is the curved surface area of cylinder base? We don't want. It's a tent, no? So 2 pi RH plus pi RL. Okay. And we know the radius and pi is common for both. So pi r into 2h plus L. Pi r into 2h plus L. A cylinder, that's why we take h1, height 1. First height is for cylinder. Okay, let us replace all these values. Pi r into 2h plus L to obtain the surface area of the tent. What is the value of pi? 22 by 7. Radius 12. 2h1. Height of the cylinder. What is the height of the cylinder given in the question? Yes, it is 8 meters plus L. We calculated as 13. So 22 into 12 by 7 into 2 8s are 16 plus 13, 29. So multiply and divide. We will obtain the value of surface area of tent. Okay. So we will obtain 7656 by 7. You do the calculation in the working column. Okay. And divide. We will obtain 1093.71 meter square. Understood the first part? Now the second part is area of canvas required to make this tent, allowing 10% of the canvas used for folds and stitchings. We can do that. Let the second question, let the area of canvas required equal. X meter square. It is given in the question that 10% of it is used for folds and stitchings. 10% of X is used. Okay. So when we subtract that 10% from the total X, that is the canvas we used, we get the curved surface area of the cone. That is X minus 10% of X gives curved surface area of cone. So understood this? Total canvas required minus total canvas and 10% is used for stitching. So when we minus that, we get the surface area of the tent. Okay. Curved surface area of tent. That is calculated actually. X minus 10 by 100 X equal CSA. What was the value of CSA? Yes. It is 1093.71 meter square. Cancel out this. Take the LCM. 10 minus 1, 9. 9x by 10 gives 1093.71. Cross multiply x equal 1093.71 into 10 by 9. Multiply the reciprocal. Okay. Now when we multiply by 10, we get 10937.1 by 9. Divide. To divide, we get 1215.23 meters. 6 homework and question 7. There is a toy in the shape of a cone mounted on a cylinder. Cone mounted on cylinder as shown in the figure. If the height of the cone is 24 centimeter, what is the height of the cone? 24 centimeter. And the total height of the toy is 60 centimeter. Total height is 60 centimeter. So can you say what is the height of the cylinder alone? Yes, 60 minus 24. 36 centimeter. Okay. And the radius of the base of the cone is twice the radius of the base of the cylinder is equal to 10 centimeter. Radius of the cone, this cone, this one, radius equal 10 centimeter. It is given that it is twice the radius of the cylinder. So what is the radius of cylinder? Yes, 5 centimeter. Okay, 2 5s are 10, no? So twice that of radius of the cylinder is that of cone. That's why we can calculate the radius of the cylinder as 10 by 2, 5 centimeter. And it is given that the value of pi we have to consider as 3.14. How can we obtain the radius of cylinder? Radius of cylinder, we can mark it as R1 is equal to radius of cone, R2 divided by 2. That is 5 centimeter. R2 is the radius of cone. Okay, and we can mark h1 as the height of cylinder. Height of cylinder is 60 minus 24, that is 36 centimeter. And we can take h2 as the height of cone. That is given in the question, 24 centimeter. So we wrote everything here. Now the question is, find the surface area of the toy. How can we find the total surface area of the toy? Yes, you can see a base area here, and this is the curved surface area, and here you can see top portion of the cylinder, and the toy is the cylindrical portion. There is a cone shape mounted on it. Okay, so if we want to paint this, how can we paint this? That is the question. How much area we want to paint? So we have to paint the conical base, but this base of the cone is in the shape of a circle, and this base of the cylinder also in the shape of a circle, but it is connected to this. So if we watch that face only, you can see like this. This is the base of the cone, and this is the base of the top of the cylinder. So we want to paint this area only. That means base area of the cone minus base area of the cylinder. This portion. Okay, this portion means base area of cone minus base area of cylinder, and this is the curved surface area of cone, this is the curved surface area of cylinder, and the base of the cylinder also. So what is the total surface area? Total surface area of cylinder, not cylinder actually, toy, area of the toy equal CSA of cone plus base area of cone minus, we want to minus this common part, no? Base top area of cylinder. Then we want to add the curved surface area of cylinder. CSA of cylinder plus we want to add the base of the cylinder also, no? This is the base of the cylinder. Base area of cylinder. We know all the equations, just apply that. Which all portions we have to consider? CSA of cone, base area of cone, and minus that top portion of the cylinder, then plus CSA of cylinder and the base of the cylinder. All these portions we want to add to get the total surface area of the toy. Let us calculate it. Surface area of the toy equal curved surface area of the cone, that is pi r. We took a r as r2, second radius, r to l, plus base of the cone, pi r2 square. Then we have to minus the top area of the cylinder, that is pi r1 square. Then plus we have to add the CSA of the cylinder, 2 pi r1 h1, okay. Then base area of the cylinder, that is pi r1 square. Okay, these are the areas to be added and subtracted. Okay, here you can see pi r1 square and pi r1 square, no? So we can cancel it out. Here common is pi into r2l plus r2 square plus 2 pi r1 h1. Okay, 2 pi is not there, 2 r1 h1. Okay, so we can calculate it. 3.14 into r2. What is the radius? 10 into l. We calculated l? No. So we have to calculate l. How can we calculate the lateral slant height? Yes, L equal to square root of, here h2, height of the cone h2 square plus r2 square. Why we marked h2 and r2? To differentiate it from that radius and height of the cylinder. I marked for cylinder r1 and h1. That's why I marked here h2 and r2. Okay, so that is equal to 36 square plus 10 square. 36 no, R2, H2 is 24 square. 576 plus 100, that is 676 no, square root is 26. So here is 26 plus R2 square, R2 is the radius of the cone, square 10 square, plus 2 into R1 H1, R1 means 5, H1 is 36. Okay, let us do the calculation. 3.14 into 26 into 10, 260 plus 10 square is 100 plus 2 5s are 10, 360. Okay, add these values. 3.14 into 260 plus 100, 360. 360 plus 360, 720 into 3.14, which gives the area of the so total surface area of the toy. So multiply in your working column and calculate the value. So we will get the value 2260.80 centimeter square. Okay. Now question 13. An open cylindrical vessel of internal diameter 7 centimeter and height 8 centimeter stands on a horizontal table. Its height is 8 centimeter. So we can see this is an open cylinder of height H1, we can mark 8 centimeter. It's placed on a table, horizontal table. Inside this table, and the diameter, internal diameter is 7 centimeter. This total 7. Okay, then can you say what is the radius? R1, it's 3.5. Half of 7. Okay. Now, there is a, inside this is placed a solid metallic right circular cone. Inside this cylinder, we place a solid cone shaped is placed, and the diameter of whose base is 3.5 centimeter, and the same radius is taken as the diameter of the cone, and the height is 8 centimeter. So to the brim. Okay, total height of the cylinder is same 8 centimeter, and that of this cone also H2 we can mark 8 centimeter. Radius is diameter of the cone is 3.5. So what is the radius of the cone? It's half of it, no? Yes, 3.5 divided by 2 is the radius of the cone. And now the question is, find the volume of water required to fill the vessel. Okay, the cone shape is placed inside. There is a solid metallic cone is placed inside. So what is the amount of water we need to fill the tank, fill the vessel? How can we find this? Is it equal to the volume of the cylinder? No. We have to subtract this shape also. We don't want the water in this portion, no. So volume of cylindrical vessel minus volume of cone shape gives the volume of water we need to fill the tank. Okay, let us do that. So we can write it R1, radius of cylinder. Okay, cylinder radius is 3.5 centimeter and height H1 is 8 centimeter, and cone we take R2 as the radius, it's 3.5 by 2, and H is same 8 centimeter. Okay, how can we obtain the volume? Yes, volume of water required to fill the tank is volume of cylinder minus volume of cone. Understood? So how can we mark that or find the value? Is equal to, what is the volume of cylinder? Pi r square h. Okay, pi r1 square h1 minus volume of cone 1 by 3 pi r2 square h2. Okay, that's equal to, pi is common and h also common, no? H is 8. Okay, we can write pi into R1 square. What is R1 square? 3.5 square. H1 8. 1 by 3 pi into 3.5 by 2 square into H2. H2 means 8 itself. Okay, that's equal to pi into 8 is common. 3.5 square minus 1 by 3 into 3.5 square by 2 square, that is 4. And also we can take the 3.5 square outside, no? That's equal to 22 by 7 into 8 into 3.5 square. These are common values. 1 minus 1 by 12. Okay, that is equal to 22 by 7 into 8 into 3.5 into 3.5. We can cancel out 7 and 3.5. 0.5 into 12 minus 1, 11 by 12. 11, 6. Okay, so multiply this. 11 into 8 and 6 we can cancel. 3 2s and 4. 4 into 0.5 into 3.5 into 11. That gives the solution. Okay. So that is equal to 282.33 centimeter cube, which is the volume of the water we require to fill the cylinder. Now the next question is, 13th question, second part. If this cone is replaced by another cone whose height is, height of new cone, one 3 by 4 centimeter, that is 7 by 4 centimeter, and radius of whose base is 2 centimeter. Radius of new cone is 2 centimeter. When the previous cone is replaced by this cone, you want to find the drop in the water level. So how can we find the volume of new cylinder? Volume of new cone. 1 by 3 into pi into r square h. 2 square into 7 by 4. 2 square and 4 cancelled. So 7 pi by 3. That is equal to 7 into 22 by 7 into 3. Cancel this. 22 by 3 is the volume of the new cone. Now we can say that the volume of water which comes down equal volume of the first cone minus volume of second cone. Okay, what is the drop in the, or volume of the drop? What is the volume of water which drops down? Yes, that is equal to volume of the difference in their volumes of first cone and the second cone. Let us equate that. Volume of the water that comes down is in the shape of the cylinder, no? The cylindrical shape, the volume of the water comes down, and let x be the height of the water which comes down. Let x be the drop in the water level. So the water falls down or drops down in the shape of cylinder. So the volume of water comes down is pi r square x. We took the height as x is equal to volume of the first cone minus volume of the second cone. First cone we calculated, no? That is 1 by 3 into pi into, that is 22 by 7 into, what was the radius of the first cone? The diameter of the base is 3.5. So the radius is 3.5 by 2 and height 8 minus, and the second one is 22 by 3. Okay. So we can cancel this 2 2s are 4. 22 into 3.5 square into 8. 3 into 7 into 4. 2 is here. And 7 and 1 3.5 cancel. 0.5 we will obtain minus 22 by 3. Know that the radius of the cylinder is diameter of the cylinder is 7, so the radius is 7 by 2. Height is x. 22 into 3.5, 1 3.5 square. So 1 3.5 and 7 we cancelled, we obtained 0.5 into 2 by 3 minus 22 by 3. That is 22 by 3 we can take outside. It's 3.5 into 0.5 into 2 is 1, no? Minus 1. Here it is 22 by 7 into 7 square, 49 by 4x. From these two sides 22 we can cancel, and x equal to 1 by 3 into 3.5 minus 1 is 2.5, and this 49 and 49 we can divide to the right side. 7 and 4 we can multiply here. 7 7s are 49. So 2.5 into 4 by 3 into 7, 21. So 10 by 21. So which is the drop in the water level. Understood? Just equate the volume of the cylindrical shape is equal to the height x is equal to difference in the volumes of the two cones, so that we can find the level or drop in the water level in that particular cylinder. Understood? Okay, these are the important problems from this chapter. Learn the chapter well and do your homeworks. Thank you all. Have a nice day.